So we've got this situation. We have, it's called the Frustum. So it's what's called a truncated cone. Okay, it's got here a truncated, chopped off cone. So you've got a whole cone, but they take the top off. So this is the shape of a spacecraft. All right. So you're being asked to draw a diagram and label the dimensions of the diagram. We've done it. Okay, cool. So let's have a look at doing that. So we've got to draw the diagram. So you're going to be doing this. So we've got basically, it would be a cone, but the top's chopped off the cone. Right, that's too bad actually. Alright, so you're going to draw something like that.
On the next one?
In your books. So we'll put a title, the Frustum activity. Okay. Also known as truncated. We're going to draw that, and then we've got to put the dimensions of that from our information. So it says the height of the crew section is 3.3 meters with a large base of 5 meters. So we need to put that information in. So the height, okay, is that. And we've got the and the base diameter. So we've got those two pieces of information. So what we got? 3.3 meters and 5 meters. And then what? 2 meters for the top. Got this diameter of the smaller one. So it's 2 meters. Now it says, using similar triangles, so using similar triangles to find the height of the smaller cone that has been chopped off. Alright, so how do we do that? Do you know what it means by similar triangles? It's not really kind of just saying it's sort of something similar in that sense. So if I think of it just as a triangle, right, if I look at it just at the side of the triangle, we've got the height of the big triangle, okay? And what we're imagining is that we take this and we chop the top off, and that's what then becomes the three-dimensional frustum, yeah? Got that? So, if you think about it, so that purple one is a big triangle with a height, okay? But what we've also got now is we've got a smaller triangle here, but they are similar triangles. So, is there anyone that can remember what we mean by that? Say it again. It is a trapezoid underneath, but we don't want to think of it like that. Actually, we want to think of it as two separate triangles. Right, similar shapes. Go on. Say it again. Oh, we could do that. Again, probably isn't going to help us. So we're going to use similar triangles. So that's what we need to figure out.
Go on. Find the volume or area of the triangle, the big one and then the small one, and then take it away.
But what we're looking for is this understanding what similar shapes are. Right, so similar shapes, so especially similar triangles like this, I know that the angle of the little triangle and the big triangle at the top is the same, right? Because it's shared. Now, this angle, okay, I'll label it with 2 little lines because it's different to the top one, is exactly the same as this one. How do we know?
Because if you keep extending it evenly, it will match that larger triangle.
Exactly. So if I keep drawing lines across, I just get more and more similar triangles as I get bigger and bigger. So this angle is the same, and then this one here is the same as. So these are 2. The purple one or the pink, whatever you want to call it, and the red one are similar triangles because the red one is a smaller version of the big one. So all the angles are the same. So what do I know about that then? Well, what I'm looking for is if that's the height of the big one, I've got the height of the small one. Okay? So, what can I work out? Well, I've got some dimensions here. This is 5 meters. This is 2 meters. Okay. Now, what we can work out is the proportion that it's been enlarged. Okay? So I can say similar shapes are enlarged. Okay? So in this case, what I can say is it's 2 meters times what gives me 5 meters. How would I work that out? 5 divided by 2, yeah. So the question mark is 5 divided by 2. Which I could leave it like that, or a lot of you will probably want to turn it into a decimal, won't you, which is 2.5. So I know, because they're similar shapes, every length in the triangles, from the red one to the purple one, has been multiplied by 2.5. So these heights, whatever the small one is, if I multiply it by 2.5, I get the bigger one. That makes sense? Because everything gets multiplied by 2.5. The heights, the lengths, everything is 2.5 bigger. Yes? No? So what I did was I used one piece of information I have, which is the 2 meters to the 5 meters. So I know that. Why am I allowed to use the 2 meters and the 5 meters? Why have I chose those 2 numbers to compare? Yeah?
Because it's the base length of the frustum.
Yeah, exactly. It's the base of each triangle. Right, so I've got to compare the same sides to figure out how much bigger it is. I can't look at this side and compare it to that one. So I can take the base of each triangle and I say, right, if I can work out how much bigger that is, then I know how much bigger everything else is. Yeah? You can watch the video. All right. Give you a moment to write that down, those people that are not writing it out. So what is... We're trying to work out an unknown value, yeah? Okay? When we've got an unknown value, we need to start using what? X, or algebra or something, yeah? So what I'm going to do is I'm going to call this little one H. For height. I could call it X, but I'm going to call it H. Okay? What do I know about the height of the big one?
H times 2.5 X.
No.
Isn't it already?
Not, well, you are right, but it's another X. But we've got something else we could use. It's not quite 3.3, is it? It's 3.3 plus
H.
H, isn't it? Think about it. that bit here, up to that point, is, we've got on the diagram 3.3 metres. This part is h, so in total we have h plus 3.3. Almost, yeah. So now what we can do is this. We can set up an equation with the information I know. And the information is like this. I can say h times what? No. 2.5. Good. That's just off the top of my diagram. But h times 2.5 has to equal what?
X.
No.
3.3.
No.
H.
Which is?
X.
H plus
H plus 3.3. Okay?
Wait.
So I take h, if I multiply it by 2.5, I get h plus 3.3. Now sometimes it's confusing and shit, but how can I have, I've got h on one side, but how can it now use it? But that's what we've got, isn't it? We know that bit is the same as that bit, and we know that bit is 3.3, so this whole height must be h plus 3.3. And times by 2.5. Yeah, go on. Question? No? Yeah? Question, why isn't it just 3.3 times 2.5?
Because it would be 2.5 times what? 2.3 divided by 2.5.
What 3.3, remember what we're doing, we're working out the relationship between two what's? Two triangles. The 3.3 is only the height of a trapezoid. We're not using the trapezoid, we need the whole triangle. So do you remember I said the first one I drew was the whole pink one? Right, the 3.3 is only that, so if I were to extend this to make the cone, I'd be doing that, yeah? And you could see, I can't quite reach, but the extra bit on there, well that's the 3.3, but I need the whole cone thing, yeah? So the 3.3 is only the bottom bit, it's not the whole triangle. So I need to do 3.3 plus the h. I've still not worked out h, but I've got h times 2.5 equals h plus 3.3. Now, if I just rewrite this slightly as 2.5h equals h plus 3.3, are you happy enough with that? Just because I should rewrite this using proper algebra, which is you put the numbers first, and if we've got time symbols, we don't have to write them, yeah? So all I've done is rewritten it using rules of algebra. So I know you've done some algebra in M2. So if I try and solve that, I'm trying to find h. So how would I do that, Nick?
Did you divide 2.5 by 2.5?
I wouldn't at this moment, actually. I mean, you could say that is possible. Right?
Do you minus 2.5 from 3.3 and itself?
I don't, because 2.5, this is going to sound funny, but the 2.5 is not a 2.5. The 3.3 is a 3.3 meters, right?
Oh.
But the 2.5 is not a 2.5 meters, is it? It's a times by 2.5. So I can't subtract that 2.5 from the 3.3. But what does the 2.5 actually tell you? It's how many h's you've got on the left hand side. I've got 2.5 h's, Daniel, haven't I?
Yep.
And how many h's have I got on the right hand side?
X.
1. X, start with X. I've got 2.5 h's here, I've got 1 here. So actually my next step to try and simplify is, okay, so I do that by, I'm going to subtract my h, because it's h plus 3.3, so if I subtract h, and then I do it on this side as well. So what's h take away h?
0.
0, so I end up with 0 plus 3.3, which equals
3.4.
3.3. There's the potential tricky point is what is on the left-hand side.
Isn't it just 2.5 minus h equals 30?
It's 2.5h minus h is,
H. 2.5.
0.
it's not 2.5.
Minus what?
I've got, think of it this way, remember with maths you always say your thing, so I've got 2.5 h's. If I subtract a h, I'm left with
Oh, 1.25.
not
1.5.
1.5.
1.5.
Oh,
Yeah.
I said that.
Why make? Yeah, you did early on. Yeah. So I can have 1.5 h.
Yeah, you did say that.
I said that like 5 times.
Did you? I didn't hear you. Sorry. There's people around
It
you.
was like what?
People around you shouting on things. I did hear it from that corner. Then you have the glow that you know you were correct, and everyone else around you was foggy in the water. The reason why I was a bit missed because I know Emily said correct first time, but then started saying incorrect things.
I was
Confused.
because you didn't say it was right.
No, I didn't say it, but you didn't give me a chance.
You done that.
Okay, do you get that? Does everyone get how 2.5 h's?
Yes.
If I take away a h, it's like saying if I've got 2.5 cakes and I subtract a cake.
So when you subtract a cake from 2.5 cakes, you get a half a cake?
1.5.
cakes?
I get 1.5 cakes.
Okay.
So let me think of it this way. 2.5 h's looks like this. 1 h plus another h plus
Half a H.
half a h. If I subtract,
half H would just be a
if I subtract a h, I get rid of one of my h's, so I'm left with 1 and half h's.
But that's not a half.
I do the same thing on
Dad.
both cakes.
Yeah, I would have the line. It wouldn't even have to.
Let's not get into the semantics of
It doesn't matter.
very massive. Okay,
This is a T.
what's the final step then?
2.
If 1.5 h's, yeah, if I've got 1.5 h's is 3.3, I need to divide by 1.5.
On each side.
Isn't the I said that. The area of the wait, I'm tiny one, 1.5, and then 2. And then you like
Well, let's work out. So what is 1h? If I've got to do 3.3 divided by 1.5, what's the answer? We'll need calculators.
3.3.
I don't have it on.
Daniel, you've got a calculator, do it.
Oh, what is it?
2.20.
So we think it's 2.2.
2.2.
Good. That means, everyone, pay attention. This is not the point to get lost. If I give you a question like this in the test, you'll go, that was too difficult. And then I'll point out the fact that you lost attention halfway through being told how to do it. So we've been told that h is 2.2. So what can I do now?
3.3 plus.
Good. Yeah. So if I go up here, look. All right. I now know back in my diagram that h is 2.2, and the height of the bigger one is h plus 3.3 is 2.2 plus 3.3, which equals
6.6.
5.5.
okay. Okay. All right. That took a while. Please stay focused. So we've now got the total height of the cone. words in the past about you carry on talking while I'm stay focused. Let's not go back to that point. It now says, so we've got the total height of the cone. So if we turned our frustum into a whole cone, we've got that. Okay. In fact, what we've now got, if you think about it, if I separate things, I've now got a big triangle that would make up the cone if it was 3 dimensions, and I've got a baby one at the top, and I now know lots about them, which is the height of this one is 2.2 meters. I know the height of this one is 5.5 meters. I know the base of this triangle is 2 meters. I know the base of this one is 5 meters. Okay, take a moment to write that down. Why do we multiply by 2.5?
Because the big triangle is 2.5 more than no triangle.
Exactly. Remember, we did similar triangles, so the similar shapes. When we know it's similar shapes, we have to figure out what we multiply by. And how did we figure out it was multiplied by 2.5? How did we work that out?
Divided by 2.
Yeah, so we used these two, the 2 and the 5, to figure that out. And then we used that in our way to work out what h was. So if you haven't written all that information on your diagram, you're not going to know what the times 2.5 was for. And I can guarantee that at least one of you, if you were trying to use your notes to work out a new one, would just put 2.5 in, because you don't know where it comes from, even if it wasn't 2.5. You know, even if it was supposed to be like 3 or something. Okay, so make sure you know. So this is actually called the scale factor of enlargement. Okay? Scale factor is the times 2.5. Okay, so once we've got that, we've worked that out. So our next stage was this. So we've got,
Base times height divided by 2.
well, that would be for the triangles. So we've got all the information about triangles. However, it does say calculate the volume of the Frustum-shaped spacecraft. So what are we going to do? Well, triangles are no good. We need cones. But the same idea, yeah? If we were to work out the area of the big, if this was a cone, yeah? And then work out the little cone and subtract, we would get the bit left over, yeah?
Yeah.
So let's do that. Let's work out the volume of this if it was a cone. So if I were to change, here's my, so let's say that was actually my cone, and this is another smaller cone. Right, so now they're cones. What is the formula for the area of volume of a cone? It's not 4 of 3, because that was the sphere, wasn't it? That we did. Do you remember? So the volume of a cone was 1/3 pi r
squared h.
pi r squared. Right. There's something at the end of the unit that we talk about that's quite useful. Yes.
Is that a triangle by me?
That's a cone.
Oh, okay.
I could just say cone. I could just write volume of cone.
Just making sure.
Yeah, no.
What's a slant again? You said
The slant height is this, isn't it? So it's the volume of a cone pi r squared h, yeah?
Yeah.
So we don't need the slant height because that was for the surface area. So what's the volume of the big cone? Volume of big cone is 1/3 times pi times 2.5 squared times 5.5.
It is 35.9974158.
So you've worked that out. Can we just verify that by checking? Someone else do it as well. What did you work out, sorry? Major?
40. So if you were
40.
keep going. 40.0. That's rounded.
Oh, so it was 39 point something, was it?
0.997.
Oh, well, let's do that. Start with, we can round afterwards. So 39
No,
point.
it's 35. I can't see.
Yeah.
Sorry, I can't see.
Sorry. So 35 point.
36.
9.
We're now rounding.
Okay. We won't round yet. Then what's the volume of the small cone then? So we've got 1/3 times pi times what?
2.2.
No?
2.1.
No?
3.3.
What's the radius?
2. I mean,
What?
1.
1, isn't it? 1 squared. The radius is 1 meter. Here, the radius is 2.5 meters. That's what we use. This one's even easier. Times the height is
I got
2.2.
2.3038.
So we've got volume of the small cone is
2.3038.
2.3038. So 304, should we say? It's 3 decimal places.
Yeah. No, it's not too.
Keep rounding.
I rounded it. Is it 3038? Yeah?
Yes.
Alright, so then what we're doing then, if this cone is this small cone is the 2.304 and this is the 35.997, well if we take the small cone and cut it off, okay, we get left with the area of the spaceship. Yeah, just a bit. So we're going to do now.
I got 33.6.
So volume of Frustum is equal to 35.997 minus 2.304.
I got 33.6 minus actually
33 point. Go on, what?
0.693.
693. Now we're now at a stage we've got a final answer. We can round that to whatever's. So we can say volume of Frustum is now 33.7 watt. It's cubic meters, isn't it? Because we're all in. Okay.
Here you go.
Right. Give you a chance to.
What's the cone?